If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay students, welcome to lecture 3 of this complex number theory portion discussion. So today we will be discussing complex integral about. We will give introduction to this and we will see Cauchy integral theorem, simply connected region and multiply connected region. How this is done, Cauchy integral theorem. Okay then, let's discuss this first. Okay student, complex integral. Until this we have studied what is analytical function, how to form analytic functions. So the main part comes here, the analytic complex integral. Questions comes from here mainly. So complex integral, if you go here, it is simple. XY function is given, 2 points are given, z1, z2. So it is represented a integral of fz over the point from z1 to z2 dz. Now one important property, the entire analysis from now onwards will be depending on these only. If fz is analytic, then I doesn't depend on the path it follows from z1 to z2. If it is analytic, then it doesn't depend on the path it follows. Means you can move using this curve, you can move direct here, you can move, you can go through a straight line also. Whatever way you do, the answer will be same. The integration answer will be same from z1 to z2. Now from here only, if you C is a closed curve, then this integration is named as contour integral. So contour integral is nothing but it is a closed curve. You are taking interval over a closed curve. So it is denoted by you can recall this from your vector calculus. This symbol is used to represent the closed curve. Now one simple example I mentioned here so that you understand how to do complex integral. Suppose there is a function is given. If it is given analytic, if this function is given analytic fz, then you can choose your own path. But here it is not given. So in the question they have given the path. If in the question they have not given the path and this is analytic, then you can choose any path because answer will be same. So obviously we will choose straight line because it becomes very easy for us. But here given, you have to go through a straight line from this point to this point and you have to integrate this one. So because it is straight line, we are using z equal to x plus iy. If they want us to go around a circle, then we will be using polar form because then it becomes easy, because theta varies from 0 to 2 pi. Using this one, integration becomes easy. So this is given. If for circle we will assume this. So what is my del z is del x plus I del y. So you put del z here, del x plus I del y. Now the idea is what you have done in vector, you parameterized it. So same thing you can do here, x equal to 2, y equal to 2. What is the parametrization? What is the equation of this line? 0, 0, 1, 1. So it is y equal to x. You can calculate by using coordinate geometry 1, 1, 0, 0. Y equal to mx, m is here 1. So you parameterize is x equal to t, y equal to t. So dx will be dt, dy is also dt. So you can use this parameterization format. But directly also you can write, there is no issue. So whichever way you are comfortable. So you have to find a relation between del y del x. We cannot work on both. We have to change it to a 1. Either you go for both, you change to t, or you change another one to another one. So if I change del y is equal to del x and y is equal to x, we can put t also. So t minus t, it will be 0. It will be t square. It will be dt plus I dt. That's it. And what is the limit of t? 0 to 1. So 0 to 1. I have written here in x, you can change it to t also. So if you take dx common 1 plus I taken outside, I is also outside to t square dt. So if you do the integration, is easy. So don't worry, these integrations is very rare to come. The simple integration, simple theorems, it will come from where directly by seeing that answer can be given. Now coming to the Cauchy integral theorem, these are the most important parts we are going through. Very simple, very understanding and very scoreable. You can see just and you can give the answer. So before going to Cauchy integral theorem, let me state two things. One is known as simply connected region, one is known as multiply connected region. Simply connected region means there will be only one curve, and the region, there may be multiple curve also, but the thing very funny thing you see, this is the area I am talking about, this is the region, it is bounded by this curve. So you always think that I am going anti-clockwise direction. Suppose I am here and I am moving here, you can see a man is standing here. So if I am moving here, suppose if I stand in that position, so if I move here, my left hand side, you can see this is my left hand. For you it may be reversed. So my left hand should be on that region. So if I move here, so you can see my left hand is on the region. So if I come here, so again I am moving this side, so my left hand is this region. So if my entire time my left hand is covering that region only, if I complete the cycle, in total how many ways I can complete the boundaries of that region, then every time my left hand should be on that surface, then it is simply closed. Now you can see here this is a hole is there, so this the inside region I am talking about. So if so I will move in anti-clockwise. So if I move in anti-clockwise, my left hand is showing this inside area. Okay, now if I come to this circle also I will move in, because this is also boundary, so I have to complete the entire boundary. So this boundary I have completed, it is okay. Now if I come to this boundary, if I move anti-clockwise, now you can see my left hand is on this side, but this is not in the area. This is coming reverse. The area, required area coming in the right hand. You can see it is in the right hand, not in the left hand. So that's why it is known as multiply connected, not a simply connected region. Now how to convert it into a simply connected region? So you just take a small cut here. If I take a small cut here, now if I move anti-clockwise direction, suppose if I move here, so my left hand remains there. You can see now if I go here, my left hand remains here. You can move around this. If I go here, my left hand, I have shown you the left hand here. If I go here and then if I go anti-clockwise, your left hand is always there. So this area is covered using my left hand only. So it is converted into simply connected region. But here the thing you have to check here is C1 direction remains same anti-clockwise, but C2 direction is changed. It became clockwise. So anyway, we'll see. It's just to give an idea how to convert a multiply connected, because in the theorem you will get simply connected region, multiply connected region, so you don't get confused over that. So what is the theorem? Some main great theorem that is coming of integral Cauchy integral theorem is, if your FZ is analytic, if it is analytic at all points, inside and on the closed curve, inside also and on the closed curve also, on the curve and the inside, contained in a simply connected domain, if it should be a simply connected, then the answer is 0. Integration answer is 0 on the closed curve. Suppose you are here in a closed curve and it is analytical everywhere and it is a simply connected to, so if you take integration over this curve, the answer is 0. Now for multiply connected region, now for multiply this, suppose you can check this multiply connected region, this one. So I have done little bit, this one I have converted into simply. Now if I take integration, what path I will follow? Suppose I start with what I have started with AB support. Suppose I start with this point. Suppose I start with this point, A to B, then this curve C2, then B to A, then C1. The entire integration will be 0, because now it is converted into simply connected, and simply connected answer is always 0, as they have mentioned. So it is simply connected. So if you see AB, then C2, then BA, then C1, total sum will be 0 from this theorem, from Cauchy integral theorem, because it is converted into simply connected. Now because it is converted into 0, now AB and BA will get cancelled out, because both are just change in direction. One is this way, one is that way, and the value remains same. That will be only plus and one minus, because AB is going this one, B. So AB and BA answer will be just a negative sign difference. So this will cancel out. So C1 becomes minus C2. So you think, what is this C2? C2 here, you think, what is the direction of C2 I have considered here? If you see the direction of C2, here the direction of C2 was changed. It was changed from, it is clockwise now. But what is original complex integration? We always consider anti-clockwise. So this is clockwise here. So with clockwise you are getting a minus sign. So if you want to change it to anti-clockwise, then this minus sign will go on. I am changing this clockwise into anti-clockwise, so another minus will come. So this minus minus plus positive. So ultimate thing said that the contour integration over C1 is become the C2. That means you can understand in this way, because this area it was analytic here everywhere. So you take integration over C1 or C2 same, because C1, so this area will give 0. So ultimate thing you will get it here C2. That is the physical meaning. Suppose this is my C1, this is my C2. So this area they have defined, and the function was analytic here. So if it is analytic, we know 0. So here it is 0. So only thing is left is C2. So you can think of a coconut. So if you are taking out the outer scalp, so the main thing remains is the inside that coconut, that water and that coconut. So outside it is nothing. The answer is 0. We know that we will not get anything in the outside. We will take out this outside, but we will go inside, then we will find the ultimate thing. So that is the physical meaning you can think of. So C1 means you go the outside, you come to C2, that's only. So you can come as close as you want to be that region. Suppose this point is a problematic point. Suppose this is a problematic point. So you make a circle around it, and you take, otherwise this will be 0, I know. So you come to this only. So you think on this only, the answer will come. Now suppose there are not single hole, there is a multiple holes are there. Earlier there was only one hole. Suppose this is a plate and there is a hole. Now if there is a multiple holes are there, then what will it will be? It will be the entire contour integration, this one. So these things will be 0, we know. So ultimately it will come to these and these and these. So summation of C1 plus C2 plus C3. All these are in anti-clockwise, you think, not in that way I have mentioned. Here it is converted into simply connected, then you do the derivation, finally you will come to this integration. So these are all in anti-clockwise direction. Okay, then we'll left with small things, so we'll do it in next class, I think. If you liked the video, then press the like button and please give your valuable comments in the comment section.